This is SpaceTime, Series 23, Episode 62. Coming up on SpaceTime. Is it time to begin weaponizing space? Evidence of what could be recent volcanic eruptions on the Saturnian moon Titan. And Rocket Lab launches its 12th mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
American defense leaders have presented the official flag of the new United States Space Force to US President Donald Trump in the Oval Office. The new flag, which bears a striking resemblance to the Star Trek United Federation of Planets Starfleet insignia, will hang in the White House alongside flags from America's other military services, the Air Force, Army, Navy, Marines and Coast Guard. The United States found the need to create a separate defense arm for the space warfare arena last year in order to meet the growing threat being posed by the existing Russian and Chinese space forces, which have already begun to weaponize space. The new branch will defend American space assets, including communications, navigation, intelligence, surveillance and reconnaissance satellites. And with Australia having contributed significant funding towards some of these spacecraft, as well as maintaining a key ongoing ground support role, together with all the military benefits that provides, comes the obvious question, should Australia be looking at establishing its own space force within the ADF? Gilmour Space CEO and founder Adam Gilmour says Australia's multi-billion-dollar advanced weapons systems and capabilities rely on secure tactical communications technologies to perform, and that simply wouldn't be possible without utilising and controlling the space domain. Gilmour Space was recently awarded a contract by the Australian government to develop the technologies needed to construct a three-stage orbital rocket using its hybrid engine design. Adam Gilmour says you can no longer assume satellites are safe in orbit from an aggressor. Both Russia and China have successfully blown up orbiting satellites using ASATs or anti-satellite weapons. These include both surface and air-launched missiles as well as more advanced laser systems. Gilmour says a coordinated attack from a capable adversary could destroy a significant number of our key defence and civilian satellites within 24 hours, thereby altering our very way of life, as well as our ability to defend ourselves. And it would happen faster than any virus ever seen.
There's a growing threat and understanding that satellites are extremely vulnerable targets in space, and they're so utilised now in the Defence Force that it is obvious in any kind of a major conflict with a major power, or even a minor conflict or medium conflict with a major power, that these satellites will be targeted for destruction as the first wave of a battle. And that's pretty much accepted doctrine. And I think people for 30 or 40 years have just thought, okay, satellites are up there, they're a long way away, they're out of harm's way, we'll just pretend that they're all safe and secure. And that's just absolutely not the reality anymore. And it's critical as part of the Defence Force that you have the capability to reconstitute satellites if they get knocked out with new ones, so that you can continually have communications, navigation, and reconnaissance. It's not good enough for us to just assume that all these satellites up there are going to stay there and assume that the Americans are going to be able to replace them very quickly, because the Americans cannot, and they're looking for tactically responsive capability, as they say, and they're actively funding many companies to get there, and they have said we rely on our allies to do the same thing.
Do you think the Australian government understands that?
I'm not sure how much the government does. I know there are some people in the Defence Force that do understand that, but I don't think it's a widely understood fact.
In the old days, it was a case of let's grab a missile and shoot down the satellite. It's not that simple anymore, is it? Not with targeted electromagnetic energy being able to absolutely pinpoint hit a satellite from the ground.
Yeah, and there's other technology the Russians have just demonstrated where they can put kind of satellites up that are tracker and target satellites that kind of follow behind you and can get you in space even. So it's become a very dangerous environment up in space, and that's why the US has started a Space Force.
Indeed.
There's some programs that Defence Department's working on. DEF 799 is one of them, where they're going to spend billions of dollars putting up sovereign-owned, not necessarily sovereign-made, and I want that to change. I want them to be made in Australia by Australian companies, but at least for now, it's sovereign-controlled satellites out to 2030 and 2035. And there'll be quite a few of them, and they will have to be defended and they will have to be replaced if they're targeted.
A way of getting them up there, of course, is what you guys are working on. Now, you recently signed a contract. It's a development contract with the Australian Defence Force.
Yeah, it's a collaboration contract where they've agreed that they will help us develop technology, and we've got a list of different subcomponents of the rocket that they might help us with. And we will also be looking at other opportunities in the future to work together on projects. But it is not a contract to say, go and build us a rocket. I wish it was, but it isn't.
Do you think that's far off?
I hope not, but, to me, a year is a long way away. I think it's inevitable that it will happen one day. It's just how soon.
Where are you at with your development now with the hybrid rocket? Any successful test recently?
Yeah, we have. We've done a lot of successful engine tests, and we've got more to go, and we'll probably continue engine testing throughout the end of this year and into early next year. But we've also been working very hard on all the other bits and components of the rocket, like the software and the avionics system and some of the structural stuff, the fuel tanks, all of these things. We're all working together in co-development. And by the end of the year, our goal is to have tested the majority of the subsystems of the rocket so that next year we can start integrating it and building the actual rocket.
You did a successful sounding rocket test back in, was it 2016?
Yes. Yeah, that was quite a simple, low-powered rocket, but it used 3D printed fuel, and we made everything in the rocket. And that was really good. Now, we tried to launch a much more sophisticated rocket last year, and we had a failure. One component failed, and that's all you need in a rocket. But we learned a lot in the build of it, in the design of it, in the testing of it, which is serving us well as we build a bigger, more complicated vehicle now. So we've got a main engine that we use on the first and second stages. And on the second stage, it's just a single engine. But on the first stage, it's four of them are clustered together. And that gives you enough thrust to take the payload to space.
What are the advantages and disadvantages of the different types of fuels around these days?
Yeah, we're not 3D printing the fuel anymore. It's a different construction, but we're still using a solid fuel and a liquid oxidizer. So one of the big differences is safety. Because our fuels are different forms of matter, they can't combine and explode. So we can never have these spectacular explosions that the other type of rockets can have. The other thing is hybrid rockets can scale up quite easily. So you can do a test of a smaller version of a hybrid and know with some good certainty that when you do a bigger version of that, it's going to work. Liquid motors do not have that capability. You double the thrust of a liquid motor, it's a brand new engine again. It is not the same with a hybrid motor. And hybrid motors can throttle aggressively. We've tested our engines under 10% thrust, and they can stop and start quite easily. Liquid engines have a lot more trouble doing that, and solids absolutely cannot do that. Once they're turned on, they can't turn off.
Do you guys have a timeline as yet for how your testing's going, what you want to do next? Where would you like to be in a year from now?
Oh, we do. In a year from now, we want to fully test all of our rocket motors and be very close to starting construction on the rocket itself, and we want to launch it in 2022.
Do you need a big launch pad for the sort of rockets you're looking at launching, or is it launch it on a spine and that's it?
Yeah, we don't need a big launch pad. Very, very simple infrastructure for this rocket because it's not a huge rocket. And so, we're talking to the Queensland government about getting a launch site in Queensland, and we think, for the first few launches, there doesn't need to be a lot of infrastructure, literally a concrete pad, some buildings to assemble staff, and a launch tower that we'd make. So, we're trying to do this with as lowest cost as possible. Most of our competitors are in countries that very well fund technology development in rockets from a very early stage. Particularly the Americans, but also the Europeans. The British are now coming out with rockets, and the British government is supporting those rocket companies. And so far, we've had almost no money from our government. We've been around for 5 years. We've extensively tested technology. We've got a big team of people working on it. We've hired engineers from all over the world, and we're still yet to see any real funding. No funding from the space agency and very little from the federal government. And this is putting us at a massive commercial disadvantage to the rest of the world, as our competitors are all getting tens and hundreds of millions of dollars from their governments to help them develop the rocket. And SpaceX is the best example of that.
But I thought the whole idea of the Australian Space Agency, at least this is what the government have been touting, was this was supposed to be the rebirth of the Australian space industry, and you're saying that hasn't actually been much in the way of cash coming through.
Well, that's right. We're still waiting for the cash to come. There's some programs that are supposed to happen in the next 5 years, but it's not a lot of money in the next 2 years. It's really dribs and drabs. And it's just not enough to boost the industry to where it has to go. So more money has to come sooner into the industry for it to succeed.
That's Adam Gilmore, the CEO and founder of Gilmore Space Technologies. This is SpaceTime. I'm Stuart Gary. Still to come, evidence of recent volcanic eruptions on Titan, and Rocket Lab launches its 12th mission into orbit. All that and more coming up on SpaceTime. Astronomers studying data from NASA's Cassini mission, which explored the ringed world of Saturn and its many moons, have found evidence of recent volcanic activity on the moon Titan. The findings, reported in the Journal of Geophysical Research, show what appear to be volcanic craters near Titan's northern polar region. Titan is not only Saturn's largest moon, but also the second biggest moon in our solar system. In fact, it's larger than the planet Mercury. Significantly, it's the only world in the solar system other than Earth where clouds rain liquid down onto the ground, forming streams and rivers that eventually flow into lakes and seas. But unlike Earth's water-based hydrological cycle, Titan's rains are made of methane and ethane. On Titan, temperatures are so cold, the water's frozen so hard it forms the bedrock. Titan's atmosphere is about 10 times as thick as Earth and is primarily nitrogen laced with methane and ethane. It forms a dense hydrocarbon haze high in the moon's stratosphere, where it's eventually destroyed by sunlight. Scientists believe it's all very reminiscent of what the early primordial Earth would have been like. This new study's lead author, Charles Wood from the Planetary Science Institute in Tucson, Arizona, says morphological features including nested collapses, elevated ramparts, halos and islands all suggest that some of the abundant small depressions in the North Polar region of Titan are likely to be volcanic collapse craters. And he believes that the apparent freshness of some of the craters seen by Cassini suggests they could be evidence of relatively recent explosive events on Titan, which could even be continuing today. And it's not just the northern polar latitudes. Similar depressions have also been detected near Titan's south pole. Wood says the close association of the proposed volcanic craters and polar lakes is consistent with a volcanic origin through explosive eruptions followed by collapse as either calderas or shallow flat-floored craters. The Cassini mission revealed many landforms on Titan that are very similar to those found on Earth. There were sand dunes, river valleys and lakes, all the results of actions by the atmosphere on the surface driven by solar heating. But Wood says the findings also show there's evidence of internal heating, manifesting on the surface as cryovolcanoes, made from melting the water ice bedrock into liquid water, which then erupts onto Titan's surface. These features are roughly round with raised rims, and sometimes they overlap each other. In fact, they're very consistent with the shapes of other volcanic landforms seen on Earth and Mars, which are formed by explosion, excavation and collapse. The fact that these features are common in polar regions near lakes of methane may indicate that methane, nitrogen or some other volatile could be powering them. This is SpaceTime. Still to come, New Zealand's Rocket Lab launches its 12th orbital mission, and later in the science report, dexamethasone being seen as a major breakthrough for saving the lives of COVID-19 patients. All that and much more still to come on SpaceTime. An Electron rocket has successfully blasted into space, carrying 5 satellites into orbit. The payloads included 3 classified satellites for the United States National Reconnaissance Office, as well as 1 for NASA and 1 for the University of New South Wales. The mission, which had been appropriately called Don't Stop Me Now, lived up to its name after initially being slated for launch back in late March. But that was delayed some 2.5 months by the coronavirus pandemic. An attempt to launch last week was also scrubbed, this time because of strong winds. The early morning flight from Rocket Lab's Mahia Peninsula Launch Complex on New Zealand's North Island marked the 12th mission for the 2-stage 70-metre tall Electron rocket.
Confirm the FTS is green and enabled for flight.
FTS is green and enabled for flight.
Top clamp is open.
And proceed with strong back retract for flight.
Retracting strong back.
On all stations, this is flight on mission code. From now on, there should be no red flags in your LCCs. And be advised, vehicle is currently green, ready for flight. VMS, flight on mission.
Go ahead.
Please confirm flight computer as goes green.
Confirm.
And VMS, please lock the auto sequence and confirm.
VMS is locked.
All stations, flight on mission. I can confirm we're go for auto sequence start. Avionics, flight on mission code.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
All AV bats are on internal power.
On the auto sequence.
Confirm stage power is disabled on all 3 stages.
External power is disabled.
All stations be advised, vehicles now on internal power. PLS, flight on mission.
PLS copies.
PLS, please begin lot skid recirc.
Copy. Beginning recirc.
Stage 1, confirm stage 1 tanks pressed.
Stage 1 is pressed.
Stage 2, confirm stage 2 tanks pressed.
Stage 2 is pressed.
Engine purge active. Deluge running.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Vehicles clear the pad.
Stage 1 propulsion is nominal.
Vehicle is supersonic.
Well, after a brief hiatus, Electron is back in the skies heading to orbit. At T plus 35 seconds into flight, we're coming up to one of the first milestones of any mission to space, passing max Q. This is the point at which Electron will experience the highest amount of aerodynamic force on its way to orbit. Let's listen into the call from Mission Control.
Coming up on maximum dynamic pressure. Pass through max Q.
Stage 1 propulsion is holding nominal. Stand by.
And there you have it. Electron has cleared max Q.
Entering burnout detect mode.
AOS Chatham Station.
Coming up next is main engine cutoff, or MECO, which occurs when the 9 Rutherford engines shut down after exhausting their fuel reserves. Upon shutdown, the empty stage is jettisoned so that stage 2 can ignite and continue on its journey to low Earth orbit.
Altitude is 50 kilometers. Speed is 1.6 kilometers per second.
MECO confirmed.
Stage 2 ignition confirmed.
That's the call we're looking for. We've had successful MECO, clean separation of Electron's first stage, and ignition of the vacuum-optimized Rutherford engine on Electron's second stage. We're approaching T plus 3 minutes into this mission with fairing separation coming up next.
Fairing separation complete.
The fairing has separated, clearing the way for payload deployment, which occurs approximately 1 hour after liftoff. For the next few minutes, you'll be hearing the word nominal quite a bit. The latest call was from Kevin Garcia, our Stage 2 operator. It's one of our favorite words at Rocket Lab, and it simply means everything is going as expected throughout the flight.
Stage 2 propulsion remains nominal.
Up next is the battery hot swap. This step is unique to Electron and its battery-powered pumps housed within the Rutherford engines. The pair of batteries that carried us thus far are nearing depletion, so to finish the job, we swap power over to a third fully charged battery. Let's wait for confirmation from Mission Control.
HVB battery discharge nominal. Approaching hot swap.
Throttling down.
Hot swap to liftoff.
Battery jettison confirmed.
As you've just heard, we've had successful battery hot swap. Electron's trajectory continues to look nominal as we hit 6 minutes and 50 seconds into this mission.
Stage 2 propulsion holding nominal.
All 5 satellites were deployed successfully into their designated orbits. Now, while the details of the NRO payloads remain classified, details of the other 2 show that NASA's Andesite CubeSat will study Earth's magnetic field and space weather, and it includes 8 tiny picosatellites, which themselves will be deployed later. Meanwhile, the University of New South Wales M2 Pathfinder satellite will test different types of space communications architecture, as well as other technologies for the Australian government. The Electron is proving to be a showcase of New Zealand technology. It's proven itself to reliably deliver 230-kilogram payloads into low Earth orbit. And Rocket Lab isn't resting on its laurels. They're now working to make their launch vehicles reusable, having successfully guided 2 boosters back to Earth, with the ultimate plan being to use helicopters to grab the spent rockets in mid-air as they float down to the surface under parachutes. The company's also now just weeks away from undertaking its first mission from its new LC-2 launch complex at NASA's Wallops Island flight facility on the Virginian mid-Atlantic coast. Being able to launch rockets on 2 continents will give Electron and Rocket Lab a significant advantage. In fact, the future looks so bright for the New Zealand company, planning's now underway for a second launch pad on the Mahia Peninsula complex. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. British scientists say initial trials have shown a cheap, widely used corticosteroid called dexamethasone could be a major breakthrough in saving the lives of COVID-19 patients. Dexamethasone's not new. In fact, it's been used since the late 1950s to reduce inflammation in other diseases such as arthritis, severe allergies, some types of nausea and vomiting, swelling of the brain and spinal cord, severe asthma, and for breathing difficulties in newborn babies. For this trial, patients were placed into one of 4 groups: those on ventilators, those in hospital needing only oxygen therapy, those who didn't require any treatment to help them breathe, and there was a control group. Patients in the 3 treatment groups were then given 6 milligrams of dexamethasone daily, either as a tablet or intravenously for 10 days. The preliminary findings, which are yet to be peer-reviewed, show dexamethasone reduced mortality rates by 1/3 for patients on ventilators and by 1/5 for patients requiring only oxygen. There was no benefit for patients who could breathe normally. The drug works because the immune systems of those with severe COVID-19 go into a sort of overdrive, producing far more infection-fighting white blood cells, causing inflammation and putting pressure on the lungs, making it very difficult to breathe. Dexamethasone works by reducing the inflammation, thereby making breathing easier. Now, the drug's not a cure for COVID-19, and it only helps those with breathing difficulties. And of course there are side effects, such as a depressed immune system. Researchers say this new drug surpasses remdesivir as the treatment of choice for COVID-19 patients. In fact, the British Health Ministry has already approved it for use in the NHS. The drug's also used here in Australia, where a pack of 30 tablets costs just $22 under the Pharmaceutical Benefit Scheme. A new study has found that young adults aren't having as much sex as they used to. A report in the Journal of the American Medical Association claims a survey of 10,000 people in the United States comparing sexual activity found that men aged between 18 and 34 and women aged 25 to 34 are sexually less active now than what their counterparts were during a similar survey conducted 18 years earlier. In fact, the situation's so dire, researchers found 1/3 of men aged 18 to 24 said they hadn't had sex for a year. Guys who weren't married, guys who were either unemployed or only in part-time employment, and those who had lower incomes were the least likely to be having sex. And students of both genders were also far less likely to be having sex. The authors speculate that cultural changes could be explaining the drop-off in sex, with young people these days taking longer to grow into adulthood generally. But they speculate the tendency to binge-watch TV, spend more time online rather than meeting people face-to-face, and whipping out their cell phones during face-to-face meetings could all be working to limit their opportunities. Paleontologists say ancient footprints found in South Korea might have belonged to a 2-legged crocodile. The findings, published in the journal Scientific Reports, could reshape previous research into ancient reptiles. The well-preserved 18 to 24 centimetre footprints were previously thought to have been made by giant pterosaurs walking on 2 legs to protect their wings. But the authors argue they're actually more likely to have been made by crocodilomorphs, which are ancestors to modern-day crocodiles, alligators and caimans. The size of the footprints indicate a body length of around 3 metres, while skin traces and clear impressions suggest heel-to-toe walking. Well, here's a question I think pretty well everyone's been asking over the last few months. What sort of person hoards rolls of toilet paper during a pandemic? Well, the answer, it seems, is that, firstly, they're likely to be Australian. Australia, it seems, led the world in over-enthusiastic dunny paper purchasing when COVID-19 first hit, and it was the notoriety of that surge which then triggered the hoarding of toilet paper in other countries. Now, a report in the journal PLOS ONE has actually looked at the type of person who bulk buys bog rolls during a crisis. Swiss and German researchers surveyed some 1,029 adults from 35 countries, finding the most likely people to stockpile toilet paper were those who perceived COVID-19 as a major global threat. Also, people who were generally more easily worried and anxious were likely to be hoarders as well. And the third group were people who were naturally really well organised. They also found older people were more likely to hoard toilet paper than younger people. And Americans, it seems, stockpiled far more toilet paper than their European counterparts. But then again, bidets are a big thing in Europe, not so much in the States. Oh, Shakespeare, who once asked the question, what's in a name? And for a bunch of anti-vaxxers and fluoridation objectors, it seems a lot. They've formally changed the name of their political party in order to deliberately hide their true agenda. What all this means is that the political party formerly known as the Involuntary Medication Objectors Vaccination Fluoride Party will now go into the next election renamed as the Informed Medical Options Party, which, if nothing else, is certainly false advertising. In fact, the name change raises the obvious question. If their policies are so good and worth standing for, then why deliberately hide them? Medical experts claim it's all part of an attempt to conceal the party's true agenda and appear more mainstream. Tim Mindham from Australian Skeptics says despite formal objections by the Australian Medical Association as well as Federal Health Minister Greg Hunt, the Australian Electoral Commission has found the name change meets the requirements of the Electoral Act.
The last election, you might remember, there was a party going for Senate places called the Involuntary Medication Objectors (Vaccination / Fluoride) Party. It's anti-vax, anti-fluoride, that sort of thing. It's a bit of a conspiracy theory party, a little one. They didn't get a lot of votes. They didn't get anyone into Parliament, thank heavens. It might be because their name was totally unwieldy. So they've now changed it to the Informed Medical Options Party, which a lot of people, especially medical experts, have objected to because it makes them sound like they are informed, they have something to do with medicine, and they're talking about options, which none of which are true. They are still the same anti-vaccination, anti-fluoride party. They're just trying to go same message, different name.
This is like the logging industry calling themselves the pro-tree party or something like that.
Yes, that sort of thing, yes. I mean, it's happened a lot of different groups setting up different things, but this was set up by the fellow who's the husband of Barbara O'Neill, a naturopath, who has been banned for life for the things that she was suggesting could be done with her treatments, etc. So, naturally enough, the Involuntary Medication Objectors Party, whatever they call it. Who
banned her for life?
The Government Department of Health, I think it was, actually. Barbara O'Neill is running a clinic, like a residential clinic and retreat up on the New South Wales North Coast. And plus she had her naturopathy practice. And she was travelling around, especially to the Pacific Islands and things, giving lectures and treatments, etc. She's now been banned from any sort of treatment in Australia, basically for promoting rubbish and dangerous rubbish. So naturally she's been pretty upset about that. And her husband has been too. So they want to have this political party, which I dare say, I'll make a prediction, will do just as well at the next election as it did at the last one.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.